Awesome, yeah, so thanks for hosting this. So I'm talking to you guys, but as I go to these Bitcoin meetups, I realize that almost everybody is more qualified than me. So hopefully I can learn as much from you as we talk afterwards. So my name is Kevin Green. For my day job, I work for Google as a software engineer. In my free time, I'm completely obsessed with Bitcoin. Just really briefly, I got into it back in 2011, right before the first ever big doxing. So that was my introduction to Bitcoin. I pretty much forgot about it for, I don't know, a year during the whole Great Bitcoin Depression of 2011. and somewhere in mid-2012, when the whole community started to come out of the woodworks again, is when I really got excited about Bitcoin. And so about 4 or 5 months ago, I reached out to Mike Hearn, and I asked him, like, how can I be involved? And he said, we have this payment protocol, you should go build it. So the payment protocol was the first I heard about it was back in 2013, when Gavin Andreessen talked about it during the big Bitcoin State of the Union address. And so it's taken that long until now for it to actually get released. So it's coming out in the next version of Bitcoin J, and it's going to be supported in Bitcoin QT.9 when that finally goes out.
So did you say it's coming out in Bitcoin J before QT?
Whenever they go out, yeah. 0.11 is finished for Bitcoin J, and it's just sort of waiting to get into the Maven repository because Mike Hearn is on vacation right now. So as soon as he gets back in a week or so, maybe there's some last minute bug fixes. Okay, so what is the payment protocol? If I could boil it down into one single sentence, the idea is that for 98% of Bitcoin transactions, the user should not have to see or know about a Bitcoin address. It's horribly unusable to copy-paste an address. And users should not be aware of it, just like they're not aware of the fact that an IP address exists. So that's what the payment protocol aims to do. So I'll talk about what it's like to make a Bitcoin transaction today, just for some frame of reference. I'll talk about what it is, and then some uses, who's building it, where it's going out, and maybe some possible future extension, future ideas. So hopefully this will be relevant to you guys, since you're developers. You'll help brainstorm and building cool stuff. And finally, I'll go into some actual code in Bitcoin J. So if you're not technical, that part probably won't be super interesting to you. Okay, so first off, for the purpose of this presentation, I went to Overstockcom and I bought something with Bitcoin. I work a lot out of coffee shops, and power outlets are difficult to come by. So I bought a portable surge protector. When you go through the checkout process, it's pretty basic. The first thing, what struck me is that all you have to give them is your first and last name, which you could fake if you wanted to, I guess. And then really all you need to give them is an address to ship to, and then you click this Pay with Bitcoin option, and you see this screen. So this screen is awesome. Right away, Coinbase is cool, and they recognized who I am. And presumably, I didn't actually do this, but if you click Pay $18 or whatever, presumably it would just do an off-blockchain transaction internally on Coinbase's servers, and it would be instantaneous. I would OAuth Overstock, and that would be a great experience, but that's a centralized approach, right? These third-party API services are awesome, but in order to have a usable experience that preserves some of the principles that Bitcoin is founded on, I think we need to make it usable to use a Bitcoin wallet where you control your money, where you're not necessarily trusting any sort of third party. So I chose the hard option. And this, if you've never used Bitcoin before and you see this screen, I mean, what do you see? First off, you just see a QR code with no indication at all whatsoever of what it's for. And then you see the send 0.0284788 BTC plus a miner fee. Most of you probably know what that is, but I assume the average user who's paying with Bitcoin for the first time won't. And then you see this long string, which is insanely difficult to read, completely inscrutable. So I actually find myself when I make payments online using my mobile app to scan the QR code, even though I'm on my same computer where I have my multi-bit wallet. I still scan the QR code on my phone because it's just easier. So I scan the QR code, and the first thing I see is that it's the exact same amount that was on the website. It doesn't make any mention of miner fees. I actually sat and stared at this screen for like a minute, no kidding, trying to decide, is blockchain going to do the right thing and include the miner fees? Do I have to add something? There's no UI on this for how to do it. I just hit send payment eventually and assumed that blockchain would do the right thing. And at this point, I'm just looking at this screen. Okay, I can hit confirm payment. Cool. Okay, so confirm payment. What that does, it brings up this screen where there's a green bar, and it's just moving at a constant rate. So it's obviously just a pre-timed thing. You're watching this bar go across the screen. And first off, can I get a show of hands? How many of you have done a Bitcoin transaction online before? Okay, most of you. Wow, almost all of you. That's awesome. So you know what it's like then when you make this transaction. To describe what it feels like to be at this moment in the middle of a Bitcoin transaction, right? You don't know if they received it. If you copy-pasted it into your wallet, if you accidentally hit a character, you've now destroyed your money forever. At this point, all you really know is that you've permanently signed money out of your possession, and you can never get it back, ever. And you're watching this green bar, right? And the green bar goes by and I get this screen. I kid you not. Wow. Sorry, we were unable to get your payment of inscrutable number to inscrutable address. The total balance is 0, okay? Seamless, yeah, okay, so let's go back to try again. And I'm back at this screen. So fortunately, I see this screen. I got an email from Overstock and it said, we've received your payment, it's been confirmed. So when I hit confirm payment again, I got this screen, success, yay. I like them on Facebook. I send a tweet. I got some retweets, you know, yay, like good for me, I'm awesome. But imagine a parallel situation where I'm back at this screen and I'd hit try again, and I think that there was some problem and I have to resend the payment. Okay, so what happens in that case? I scan it with my phone again and I send the payment. Now I've sent them the payment twice. I've permanently signed money out of my possession to Overstockcom 2 times. So how do I get my money back? Really, my only option is to call one of these people at Overstock.com and ask them nicely, can you please send me my Bitcoin back? I have no other recourse. I have to talk to somebody and they have to send me money. And just take a minute and imagine what it's like to be one of these people in the call center. Somebody calls you up and says, hey, can you send me Bitcoin? Right? First of all, you probably don't know what Bitcoin is. But second of all, these people, I used to work at a call center, and the people are not necessarily well trained, or they're not tech savvy necessarily. And so imagine giving that person the power to send Bitcoin to people. Remember that when I made the payments, the only information I gave them was my name, which I could have easily faked, and my address. So you're sitting in this chair, and somebody calls you up and says, hey, I'm Kevin Green, and I sent you Bitcoin. I'd like you to send a refund, right? How do you know they are who they say they are? You have no way of verifying. And you can't just use the address that was sent to you, because the person who paid you may not be in control of that address anymore. If you're not reusing addresses, you may get rid of your private keys that you're not using, and the change address, they may or may not control that anymore either. So also imagine telling someone over the phone a Bitcoin address. Like, could you refund it to 1 lowercase d, uppercase w, uppercase y, lowercase m? I mean, I've worked in these call centers and I've mistyped credit card numbers before. And what happens is it goes, oh, that credit card doesn't exist. But if you mistype a Bitcoin address when you're trying to process a refund, you just destroy the money forever. And now neither you nor Overstock has the money anymore, it's just gone. Okay, so the payment protocol is necessary. This, not to be all doom and gloom, here's how to solve the problem, and these ideas are all not mine at all. It's Gavin Andreessen and Mike Hearn and all the other smart guys who are involved in this. So the payment protocol works like this. The first thing that happens is the wallet asks the server for an object that's called a payment request. The payment request encodes all the information that's necessary to the payment. It essentially has 3 things. It has a list of outputs, which defines the amount and the person to pay. It includes a memo, which is human readable. The wallet displays this memo, presumably to the user. And then the third thing it includes is a PKI signature. And the signature signs all the information in the payment. It's the same exact infrastructure that's used for HTTPS. So the vendor, Overstock.com, can use their same private key that they use for their standard SSL procedures to sign these payment requests. Okay, so the wallet verifies the signature and then shows the user a confirmation, which essentially boils down to, do you want to make this payment to Overstock? Yes or no? User clicks yes, Then the wallet crafts a special message, which is a payment. It's called a payment message, and I'll describe these in detail in the next few slides. So the payment just has the signed transaction, sends it to the server. The server verifies that the transaction is what they expect it to be. It has the correct amount. It's sent to the correct people, everything else. And then the server actually broadcasts the Bitcoin transaction to the Bitcoin network in most cases. Then they send a payment ACK, and this is really important because the ACK just has a human-readable memo, and it's going to say something like, "Thank you for your payment. It was correct. It's being processed right now by the Bitcoin network. Good job." So you can immediately get feedback instead of having to wait like I did for that green bar. Okay, so I just want to walk through an example of, from the user's perspective, what does this protocol look like? It's incredibly simple. You'll see a link. It could be a button, whatever it is in the web interface. It'll say, click here to send 18 millibits to Overstock.com, right? And when you click on that, it will automatically launch an external application, which is whatever wallet the user has installed on their device. This will work on mobile, this will work on desktop, whatever it is, it will launch their wallet application automatically for them. And then it will show a simple message like this, like a dialogue that says, would you like to send it to Overstock? There's a green padlock that shows that the signature was valid. And then it shows a custom message that comes directly from Overstock. In my case, it's for the surge protector. So all the user has to do is click accept. The payment message is sent, and when they get the confirmation, they see a quick thing immediately that says, thank you for shopping at Overstock. No central parties required. Whoops.
So still need to trust the certificate.
Yes, okay, so the central authority that you're trusting in this case are the certificate issuers. So you're still trusting the same PKI infrastructure, but...
and those can't be undermined, right?
No, they're foolproof. I mean, the whole internet runs on those. If those are super vulnerable, I think we're screwed in a lot of more fundamental ways.
There are other solutions that are aiming to replace PKIs.
Yeah.
Attack.
Exactly, and that's what's great about this is that it can be extended to other types of methods of signatures in the future too. So right now it's using standard PKI, but it could use others if they were to gain adoption in the future. Okay, so that first URL that the user clicked on, here's what that looks like. It's defined in BIP72. It extends and obsoletes BIP21. So this Bitcoin colon schema has already been whitelisted in most browsers. So when you click on it, the browser will ask you to launch an external application. And when you click on it, it passes this message to the wallet. And that R equals parameter, all it is an address where the wallet can go and fetch the payment request. So that's how it knows, that's how the whole process gets started. Just for sort of a frame of reference, the old BIP21 style URIs, you would have Bitcoin, you would say an address to pay, and you would send an amount to pay, which is not very extensible. But basically, every time you pay someone using blockchain.info and you scan a QR code, they're encoding a URI that looks like this. Okay, so can I get a quick show of hands? How many of you are developers? Awesome. Okay, whew, good. Great. So the name is true. All right, the rumors are true. So here's what the actual messages look like, and I'm glad this TV is big. The most important part of this is the payment details. It defines everything that is necessary to make the payment. So it has the network, whether it's the main network or the test net, and then it has an array of outputs. It doesn't just have one address and an amount. It has an array of outputs, and that's really awesome, and I'll explain why as we go. But just keep in mind, you don't have to have just one output. And then you have a timestamp when it was created, you have an expiration date when it expires, and then you have a memo, that's the memo that's shown to the user in the dialog, and the payment URL, which is the URL where the wallet sends the payment message when the user confirms. This extra merchant data field it could be configured by, it could be anything that the merchant decides. It's just extra data. And the wallet, it won't inspect that, but it will copy it into the payment message that it sends back. So if you're doing A/B testing, you can put experiment IDs in there, you can put analytics, you can see which one converts better, and it just gives you some tools for the merchant.
What's the syntax we're looking at on the screen there?
For what?
What language is?
Protocol buffers.
Yeah, so they all use protobufs. If you're familiar with protobuf, or for those of you who aren't, it's just kind of like JSON, but instead of encoding it in text, it encodes it in a binary format over the wire, and then every language has a protobuf parser and serializers so that you can actually, you'll see this code as a payment details class in whatever language you're using. So it's really nice for a lot of reasons, and it's compact over the wire.
Out of curiosity, why did they pick Protobuf as their JSON? Because the rest of Bitcoin is all JSON.
Because Protobuf is way better than JSON for a lot of reasons. Actually, Protobufs are really awesome for, you can name it whatever you want to, as long as you have these IDs. The ID is what is actually used to, there's just a lot of reasons. Right? It was defined by Google, and it's, I don't know, it's growing in adoption as far as, but it's becoming a more standard way to make these kind of messages. So.
Okay, so just because it's better.
Yes. do we need a different? Okay. Anyway. Okay. So the payment request. This is the top level object that you actually fetch from the server. So this is the highest level thing that your wallet sees. And the payment request, all it does is it really contains a payment details object, but then it also contains the version, and then it has the signature and the information you need to verify the signature. So it's got the type, which is, it's all X509, it uses SHA-256 or SHA-1. The PKI data is just the serialized certificate chain, and then the signature is what you actually use to validate, obviously, the serialized payment request. Okay, so this payment object, here's what it looks like. Maybe this is getting a bit tedious, but it's the merchant data from the payment details. It's got a list of transactions. And this is also really important. Similar to how you can have a list of outputs instead of just one output, you can satisfy a payment request with more than one transaction. And that's awesome, and I'll explain why. You have a refund, a list of refund outputs. So if something goes wrong, if I double pay in that situation that I described earlier, the server would probably easily automatically detect that and say, hey, you're stupid, let me fix that for you, and automatically send back the amount to the refund address that you give it. And finally, you can send a memo back to the merchant. Okay, so the payment act that you get back, all it has is the payment message and a memo to show to the user. Okay, so that's the payment protocol. That's all it is. It's pretty simple. I hope that you guys walk out of here and there's no magic or mystery to it, and you can just go forth and build this into your projects. So here's some ideas. Here's how it's being used, and how we've been talking about extending it in the future. So the first obvious use case is now you can embed tipping links anywhere. You can have a link that says, click here to tip Kevin Green 1 millibit. And when they click on it, it's 2 clicks to pay. They click on the link, they hit accept, and their wallet sends a payment. Any wallet that they have installed. So you can embed these in social posts, you can embed these in YouTube video descriptions, you can embed these in tweets, you can embed these in forum comments on Reddit. You can just embed them wherever you want to. And that's awesome, that's a huge win. Another really big thing that you can do with these is you can embed them in messaging apps. You can embed them, like in WhatsApp, you can get a payment request. So you can now send a payment request to your friend as a link, and when they click on it, the wallet that's installed on their phone will automatically handle everything for them. So you can do this over text message, WhatsApp, Line, all these other messaging apps that are blowing up right now. So that's really cool. Another really big benefit of using the payment protocol is now you have provable receipts. When you combine your signed payment request with the transactions that you broadcast to the Bitcoin network that satisfy those outputs, you can now prove that you paid Overstock X amount of money on X date. So one of the future extensions, for example, to Bitcoin J or any other wallet, is that you could store these receipts in a list so that later you could do auditing, or you could look and see where you spent your money. Yeah, that has a lot of benefits. Fancy outputs. I mentioned that you can have a list of outputs when you in the payment request. So the fact that you can have more than one means that you could pay 10 people. And so today, if I had a wallet and I wanted to pay 10 people, I would have to craft that transaction in the wallet myself. But with the payment request, a server can automatically generate those outputs to be whatever you want them to be. And then the user's wallet won't even have to really know what's in those output scripts. It just knows the amount to send. It signs the inputs and sends them. So it abstracts away all of that complexity and allows the server to do whatever you want. On the server side, you could generate outputs that are M of N outputs. You could have anything. You could have fancy contracts. You could have all the things that people in the Bitcoin community have been talking about for a long time, like assurance contracts. You could create a service where the server creates these transactions for the user, and all they have to do is click on a link and click OK in their wallet. Another big one is called, can I get a show of hands? How many have you heard the term merge avoidance before? Okay, just a couple. Okay, so this is something that Mike Hearn has talked about a lot, and I'm just regurgitating his ideas. But the idea is that you want to avoid, let me just give an example. Say Alice hires Bob for a contract, and let's just say it's a $100,000 contract for easy math, right? Once Bob finishes the contract, typically Alice would send Bob a Bitcoin transaction with an output for $100,000 worth of Bitcoin, right? So now think about what happens when Bob goes to a convenience store and wants to pay with Bitcoin for a $2 Coke, right? He's going to use that $100,000 output as an input to his transaction, and he's going to have two outputs. One of the outputs is going to be for $2, and the other output is going to be for $99,998 with a Bitcoin. So now he's just exposed to the merchant how much he got paid for that contract. Users today are leaking a lot of information about their personal finances without even realizing it. And the wallets can really do a better job of helping out with this. So the payment protocol, when Bob sends Alice his payment request, instead of just including one output, he could include 100 different outputs for various amounts. They all look like reasonable human amounts of money to have in a Bitcoin address. And then if Alice's wallet is smart, instead of using the same wallet to satisfy, or using the same input to satisfy all of those different outputs, she could actually create a whole list of transactions of outputs from addresses that are not linked to each other to satisfy those outputs. So she can satisfy the payment request with 100 individual transactions. And so now they're not linked together. Bob is not exposing how much he made when he goes to make a payment. And this is really important just for people's general privacy. We're not talking about like protecting you from buying drugs. We're talking about protecting you from leaking how much money you're making to your coworkers. Another really cool thing, Andreas Schildbach has been working on integrating the payment protocol into the Bitcoin Android wallet. And this is really cool. So you can actually do in-person payment requests with this protocol using Bluetooth and NFC. So he's done some really awesome work with that. Definitely check it out when it comes out. And then there's...
That works?
I could go, I hadn't looked too much in particular, but what I think it does is it uses the... I'm not particularly familiar with Bluetooth or NFC, so I can't say definitively, but I think it uses the Bluetooth MAC address instead of the payment URL. So when they get the payment request, they can then send the payment back to the user using Bluetooth with that MAC address that they get.
But as far as the blockchain, how does it work?
It would work the same way. Yeah, so I mean, it would still create the transactions and broadcast them exactly as it would otherwise. But the problem with in-person payments is you don't have an HTTP server, right? If I'm paying you, and you and I both have Android phones, your phone isn't running an HTTP server that I can connect to. So you can't use the Bitcoin protocol as it's defined, by default. So he's done some really cool stuff to define some standard ways to use it over Bluetooth, with Bluetooth MAC addresses and NFC addresses. And again, I'm not totally familiar with Bluetooth or NFC, but it's really cool stuff. And then there are some people who are working on recurring payment contracts. So you could download a special kind of payment request that defines a contract such that you can make a monthly payment schedule or a daily payment schedule, and you can automatically set this in your wallet. And this is an awesome thing too. So what I'll be working on for the next implementation of Bitcoin J, or anyone else who wants to get involved, is the server-side implementation. Bitcoin J today has the wallet support of this protocol, but doesn't have the server-side support yet, so that will be coming in the next version.
On the server side, at one point will the seller send the ACK?
So it can work a couple of different ways. If you provide, I don't need to go back. So if you provide a payment URL in the payment request, then the wallet, by convention, will let the server broadcast the Bitcoin transactions. So if something goes wrong, it'll send a message back to the user, and the transaction won't actually get broadcast. But another way of doing it is that payment URL is actually optional. So if it's not provided, then you receive the payment request and the wallet just broadcasts the transaction as usual. So that's the convention.
Okay. Can you explain that?
Sure, yeah, go ahead.
Explain again what it communicates to the server. So if I'm doing a purchase with my Android wallet,
Mhm.
and I send a payment to the server.
Mhm.
What do I include in there that allows it to do the transaction for me?
You actually include a list of transactions, and they're signed by you. So they're fully completed transactions.
And he's just relaying them.
Exactly. So the wallet doesn't actually, it would take those transactions, and normally it would just broadcast them to the Bitcoin network.